So now that we know about the pH scale, we can apply that knowledge to figuring out how we can determine the strength of an acid or a base in a laboratory method. So there's two ways that we're going to talk about right now. First is organic dyes or indicators. These demonstrate the degree of acidity or of a solution through color change. We can use a pH meter or those test strips that we talked about earlier with litmus paper, for example. The second method is titration, and the GIF over to the right shows an example of titration. And if we were in an advanced chemistry class and we had all the fancy bells and whistles and equipment, we would definitely do this in here. But titration is the method of adding acid with a known pH to an unknown base, or the flip side, adding a base with a known pH to an unknown acid. And then when it reaches the point of equilibrium where the liquid turns like a clear color, that's when you know how basic or acidic something is. And it goes a lot more complicated than that, but we're not going to focus on that too much in this class. But just a rundown of that method, burettes dispense the known acid or base 1 drop at a time. So in that burette column, which is over here, you can see that glass tube, that's going to be the known acid or base. So we'll know that that acid, for example, has a pH of 3. Okay? And we're going to dispense it 1 drop at a time. When the color changes, the scientists calculate how many acid molecules it took to neutralize or make equilibrium and create a clear color. The endpoint or equivalence point is when neutralization occurs, and titration requires knowing the volume and the concentration of a solution. That goes back to our dilution examples that we did in class with M1 V1 equals M2 V2. We're going to talk about this briefly too, a little bit more with titration. This specific number is very important. Avogadro's number is the number of particles of any substance that is known as a mole. Okay, that's what this number tells us. This number is 6.0221415 times 10 to the 23rd. Okay? 1 mole of an element has a mass in grams equal to the atomic mass of the element. 1 mole of a compound has the mass in grams equal to the combined atomic masses of the elements. Okay? So we're not going to talk too much about moles in this class because unless you go into chemistry or science, you never will see this in your life again. I know when I took chemistry in high school, we spent probably about a month and a half talking about moles, and I don't really use it that much except to teach you guys. So we're not going to spend too much time on it, but just knowing the concept of what a mole is and the fact that it has it's equal to the grams of the atomic mass of the element. That's just basically what you need to know here. We're not going to spend too much more than that. Since titrations require working with solutions, solute concentrations must be measured in terms of molarity or capital M, and we talked about that earlier. Molarity is moles of something over liters. So a 1 molar solution is 1 mole of an element or compound dissolved in 1 liter of distilled water. What do you call a tooth in a glass of water? A 1 molar solution. Ah ha ha. Get it? Because molars are teeth. Pretty funny, I think. But we are going to stop there for now, and we'll talk a little bit about pH inside of you next. Thanks for watching.